There we go. All right. Thank you, everyone, for joining us for the Innovators in Industry Part 1 talk, which is focusing on the future of autonomous vehicles and mobility, and also kind of where we are right now. My name is Janet Callahan. I am Dean of the College of Engineering at Michigan Technological University. And this talk is focused on a student audience, students who are currently here at Michigan Tech. So I have 4 people to introduce. I'm first going to introduce our 3 alumni speakers, and then I'm going to introduce an alumnus faculty member here who's going to kind of kick us off with some slides. So beginning with, and I'm doing this in order of year you graduate. So I'd like to begin with Sean Kelley. Sean is class of '86, civil engineering. He is now with Mannik Smith Group, where he is the vice president and a principal in the company. He's a professional engineer in Michigan and Ohio. He has worked to develop infrastructure for closed system test facilities to advance smart mobility technology. And so, for example, an example of one of those facilities would be the American Center for Mobility, or what we know as M-City. So he's led the development of those kinds of facilities. So that's Sean, class of '86 civil engineer. Second, I'd like to introduce Birgit Sorgenfrei, who is class of '91 and an electrical engineer. She is currently with Ford Motor Company, where she is a driver assist technology applications lead. She's been at Ford for more than 20 years and has a long-standing career there that has included research on sensors for electrical power assist steering systems and much more. Our third alumnus is Mark Rakoski, who is a mechanical engineer. So we've got a civil, an electrical, and a mechanical. He's class of '95, and he's with Mitsubishi Electric Automotive America, where he's responsible for leading product development engineering teams for vehicle connectivity, autonomous sharing, and electric solutions. And we also have, so that these are our alumni kind of featured panelists. And then kind of co-hosting with me this evening, we have Michigan Tech electrical engineering faculty member, Dr. Jeremy Bos, who is an assistant professor in electrical and computer engineering. He is advisor to students in the robotics enterprise, where they are focused on the SAE Auto Drive Challenge 2. Jeremy is class of 2000, and then he later earned his PhD in 2012. And so with that, Jeremy, I'm hoping you can kind of help frame the conversation with by telling us a little bit about kind of where we are now and where we're going.
Yeah, thanks, Janet. So, the title here is Future of Autonomous Vehicles Mobility. Why do we care about that? Why is that important? Well, to give some context, the opportunity available to us through autonomous vehicle technologies is really about saving lives, preventing accidents and property damage, preventing injuries, which is also, is a loss of work. And there's also even an opportunity to reduce the amount of emissions per vehicle, even if we're not moving to fully electric vehicles. And this is partly due to the fact that humans are not necessarily the best drivers. So autonomous vehicle technologies themselves are not necessarily just about robo-taxis and cars driving on their own. It's actually an entire spectrum of technologies that starts over here at SAE level 0. SAE is the Society of Automotive Engineers. And they've defined as part of a standard these 5 levels of autonomous vehicles, starting at 0 and then going all the way over to full automation. And what we see on the road today is there's a lot of technologies that are in the 1 and 2 and 2+ area, and we're moving into to SAE level 3 and level 4 as we talk about fully autonomous vehicles. Some of these technologies you might see in your own vehicles if you're a student. You might also see it in your parents' vehicles. So this be things like lane keep assist, adaptive cruise control, or if you're lucky enough, so both Ford and GM have their Blue Cruise in case of Ford and Super Cruise in the case of General Motors. And GM has recently announced Ultra Cruise. And of course, Tesla has their own versions of autonomous vehicle technologies by way of autopilot. Toyota's taken a completely different turn. They want to make you a better driver via their Guardian system. And the way that all this works is we're really getting to the point now where we're just adding in technology to the vehicles by adding sensors, and this entire capability we refer to the adding of autonomous vehicle sensors, these AV sensors. These are features that we call advanced driver assistance systems as a whole, or ADAS. So if you hear people using that terminology, that's what it means. And it's a very hot area, especially for hiring folks out of universities like Michigan Tech. There's still a lot of work to be done. This is work that we're doing here on campus. In addition to the technology is not rolling out in all vehicles at once and going instantly to autonomous, it's not necessarily going to be, for example, up here in Houghton, where we get, on average of 200 inches of snow a year. We have to be able to deal with that weather in addition to everything else that's going on around the vehicle. So we're studying that up here. But that, again, gets to this idea that what was really going to happen over the lives of your careers and, our professional lives is that there's going to be changes in the automotive industry. And this plot, or this chart here, is the point is to try to tell you where there's risk to automobile sales. And the red here, or the magenta, basically saying that if you live in a warm area where it doesn't get a lot of rain, especially doesn't get a lot of snow, and you don't have something like a pickup truck or a large SUV, then it's likely to be able to replace your vehicle with an autonomous vehicle. And of course, Waymo is already operating in the Chandler, Arizona, Phoenix, Arizona area. We could see that rolling out to many other places in the desert Southwest. But if we get over to where we are here in Upper Michigan, where we're very rural, and we also get a lot of snow, there's very little risk, at least right now, until we solve those greater problems. So hopefully that gives us a bit of an introduction to the problem, or at least how the automotive industry might change. But in addition to the automotive industry changing, how we actually, I'm having sound, I'm sure you guys don't see the sound, how we use the roadways might change also. An autonomous vehicle doesn't necessarily need to stop at a stoplight. And the result here is that you can save energy and also save on pollution. Obviously, we have human drivers still in the mix. That's a little bit of a difficulty, but that's the kind of point there. And I put that in there for our civil engineering people who are participating. So with that, I think it's a perfect time to turn it over to Janet and get some questions for our panelists.
All right, thank you, Jeremy. And so students, you may ask questions by going down to the Q&A feature and just typing a question in. And I encourage you to do that because we would far rather answer your questions than to answer our questions. But we have a couple of kind of kickoff questions, but until you type something in, and you can ask anything under the sun. If nobody here knows the answer, we'll just move on. So the first question I'd kind of like to ask is, and this maybe Mark could take a stab at this, and also Birgit. So this question is, what will cars and trucks and drivers assist look like and be able to do, say, in the 5-year horizon from now? And even now, I have a car that doesn't have any of those things. And so, Mark, do you want to take a first stab, and then Birgit?
Sure. Again, I'm Mark Krakowski from Mitsubishi Electric. I lead the advanced engineering team at our office in Northville, Michigan. So Jeremy went over the level 0 to level 5, and that's just the level of autonomy. And I think the key point is it's not going to be a linear progression. It's not going to be from 0 to 1 to 2 to 3 to 4 to 5. And what's happening over time is we're seeing within 5 years, this level 2+ will be a large sweet spot within North America. And again, the Super Cruise and the Blue Cruise from Ford are two key technologies. And I think that's a balance of what is safety and affordability, as these systems are not cheap right now as well. So that's a very nice area to be working.
Oops, Mark, somehow you accidentally have muted yourself just a few seconds ago. There you go.
Yeah, and then level 4 we think is going to take off with robo-taxis. And again, Jeremy teed it up very well that in good climate areas where you don't have bad weather, or it's what we call geofence, like a college campus or something to that effect, it's an easier problem to solve and allow level 4 to succeed. So we see growth in level 4 and growth in level 2+, and then eventually level 3 and level 5 are going to become more popular as well.
Interesting. So 3 is going to be kind of left out for a while, is kind of what I was hearing you say.
Yeah, it's not necessarily left off. It's a difficult human factors engineering problem because you still have to be paying attention. So intuitively, as you're not paying attention as much, it becomes a safety risk. So actually, my company makes driver monitoring systems, which are the cameras that monitor you and make sure that you're paying attention. But intuitively, if your car is driving more autonomous, you might be guilty of not paying attention. So that's an interesting challenge that we have to be able to get control of the vehicle very quickly or teach the drivers how to use these systems properly.
Well, and Birgit, maybe you could chime in here and tell us a little bit more about kind of where driver's assist is now and where it'll be in 5 years, and anything else you want to add.
Right. So as Mark mentioned, Ford just introduced Blue Cruise technology with the opportunity that provided the drivers paying attention to the road and the driving conditions that the vehicle will take over driving of. So just to explain a little bit, we're all probably very familiar with cruise control, which is the longitudinal control of the vehicle, with Blue Cruise and GM's Super Cruise. We add the lateral control, that is the steering wheel control of the feature. And we need to make sure that the driver's paying attention because of what Mark mentioned around that level 3 autonomy. It's very difficult to re-engage the driver if they've been told by the vehicle, you're off the hook. So right now, all OEMs are offering a level 2 or below feature. We're not aware of any OEMs that are offering a level 3 or above feature. And then as we go further in the future, we just continue to add sensor capability. We add intelligence to the algorithms so that we initially are probably refining that control of the Blue Cruise or Super Cruise. We're refining so that customers feel, increasingly confident in that control, and then continue to expand the capabilities in terms of which maneuvers we let the vehicle control while the driver is still engaged, paying attention. Increase the kinds of conditions. Jeremy mentioned the inclement weather situations. That's very difficult for our sensors. So obviously adding sensors helps, but that's not always affordable from a number of different standpoints, not just adding the sensor itself and the weight that comes along with the sensor. That's obviously a negative impact on the CO2 that Jeremy mentioned, the CO2 emissions. We want to keep our vehicles as light as possible to save those CO2. But also from the standpoint of increased computing power. So if we increase our algorithms, maybe use our sensors in a smart manner in conjunction with each other, we can have a more sophisticated algorithm that can accommodate inclement weather conditions with more capability. So in 5 years, that's a lot of what we're going to see in these systems, just increased sophistication to increase capability step by step.
It's interesting. These are things I just, it's like sci-fi to me. Well, and so these vehicles have to drive on something. And so for Sean, I mean, what will roads and highways look like in 5 years? What will they have to look like? And beyond?
Well, some of the changes are going on now that aren't real visible to people. The traffic signals are getting smarter. that dynamic illustration you saw Jeremy show a minute ago on just how cars move through intersections and the improvements to energy efficiency and safety as traffic signals basically talk to the cars, and they understand the sort of rhythm of traffic volumes and behaviors through the course of 24 hours of weekdays and weekends. So you'll see things more and more that don't seem so obvious, but the roads, they're called roadside units. There are cameras, there are things out there, particularly in urban environments, that are assisting the cars to move more smoothly and efficiently and safely through navigational movements that enhance safety and efficiency of how cars function in urban environments. In rural environments as well as urban, you'll see more and more pavement markings that don't seem that glamorous, but those are going to be more and more intelligent as different materials are embedded in the pavement and the pavement markings that in a sense communicate with the cars and the trucks so that they can navigate in a way that doesn't need, as Mark was talking about, input from a human. As you get up into level 4, particularly in level 5 on these levels of autonomy. As we keep moving further and further into the future, many of the features that are common today, the width of a travel lane, the signs will not be needed at some point. This is out a long way into the future yet. Exactly when, nobody knows, lots of opinions, but safety features, guardrail. Can you imagine driving next to a cliff and not having guardrail? If a car is truly that intelligent, the odds of it taking you off the pavement will be extremely remote, well into the future. So many things are going to be changing into the future that are common today, just as we went from horses to cars. We forget to realize that took quite a few years to go through that transition that led to extensive changes in how roads look. So we're on the cusp of going through that same revolutionary transformation of what roads are going to look like, and we're right at the beginning of that transformation.
All right, and I can see we've already got some student questions. So students, you can ask questions in the Q&A feature, and if we have people joining us who aren't students, you can also ask questions. Jeremy, do you see any questions we should take now in that Q&A? There's one about diesel from a person, Kadelk35. And it's basically asking, why aren't diesel cars more common? Because they are more energy efficient as of data even 10 years ago. Anybody want to take that one?
Yeah, this is Birgit. So again, I've been at Ford for over 20 years. I've spent a large part of that time in powertrain. So, and currently I'm leading a driver assist technology team to integrate our features. But so your question is about diesel. It kind of depends on the market, quite frankly. So the North American market has not offered favorable diesel pricing, for example, and many customers are very sensitive to the price of their fuel and will, so diesel hasn't really captured the North American market. And then the other factor is a long time ago, before I started working, there were some diesels that were introduced to the North American market that were not very clean, not very comfortable from a performance standpoint. And that kind of impacted the long-term appetite for North American customers for that technology. Now, Europe is a completely different situation. They do offer diesel at quite attractive prices. And so you're going to see a much higher proportion of vehicles sold in Europe with that technology. But I think the question was really around the MPGs, the miles per gallon. And so what we've done in North America, starting in North America, is introduce newer technologies which deliver better fuel economy. So for example, GTDI, turbo direct injection engines offer a step change in fuel economy and not that much more cost in terms of putting that in the vehicle. And then the North American market after the Japanese market was a big proponent for hybrid electric vehicles. Again, another step change in fuel economy, kind of expensive in terms of putting the system in the vehicle, but a step change in fuel economy with no limitations to performance, let's say. And then I'll just make one more statement because this kind of ties back into the first question in terms of going forward. We're seeing increasingly electrified vehicles. So the next step change in addressing CO2 is really the battery electric vehicles, where there's no exhaust at all from the vehicles. But there are some challenges in terms of infrastructure available to refuel the vehicle. You might be able to trickle charge a battery electric vehicle in your garage overnight, which is very convenient. But trying to make a cross-country trip with a battery electric vehicle poses some logistical challenges.
Or driving to Houghton, for example.
I was hoping to bring a Mach-E with me in September, but yeah, I couldn't figure out how to get it to Houghton in a day. So.
Well, lots of great questions. Jeremy, do you want to pick one?
Yeah, sure. So this is actually from Colin Bannister, one of our RSE students. So he asked, with, I'll just summarize it, with level 3 autonomy, where you do have this issue of driver takeover, and also the other driver assistance technologies where you're taking the driver out of the loop, what's happening by the way of black box technology? So if there is a crash, that when the autonomous driving system is in control, they're the responsible driver, right? Or at least at the level 4 case they are. So how does that, does anyone have any feedback or any details they can share about what technology is going on there, or what technology developments are going on there?
Yeah, I'll take a stab at that. I think a lot of that's driven by, it could be regulations or, maybe acceptance of kind of the industries going forward. And I think level 3 is something that we're trying to figure out exactly as an industry and working with government and industry partnerships. There are, kind of event recorders that are not as sophisticated in your vehicle already that can understand if you hit the brakes hard or what happened just before an accident. But we have to be susceptible to current privacy laws versus obviously safety for society. And I think we're shifting that, as we all have cell phones and many other devices, we are sort of okay with giving up a little bit of our privacy. And I think the safety of the vehicle, it will be worth it. So, but it's kind of a cultural change, especially in America, where we'll have to be a little more susceptible to kind of cameras or event recorders within your vehicle to understand what's going on.
Interesting.
So
there's kind of some career questions. So Sriram asks, what are some hot technical skills for students to be competitive with industry? And that was one of the questions we had developed ahead of time, is what skills should students be making sure they have as they're working on their degrees? And
yeah,
Sean,
about that.
Sure, and then Sean too. I want to make sure.
So Ford is doing a lot of hiring. I'll just put that advertisement out there for you, especially in the driver's technology area. And the key thing is, first of all, start with your technical competency. It's required for any job in our engineering organization where you get to work on the cool stuff, to have that BS in mechanical or electrical engineering. We have a lot of need for computer science, computer engineering, etc. And then, of course, if you're working on your MS as well. So that's really the baseline. That's the basic criteria that you need to achieve in order to be considered for a job at Ford. And Michigan Tech alumni are respected for their capabilities. So you're in the right place to get the right education. Now just make sure you do well in your classes, more A's than B's. Okay. The second criteria I would say is be creative. You have lots of project team opportunities at Michigan Tech as well. Think about those great transportation experiences. So building upon that technical competency, be creative and innovate products to, really change how customers use vehicles or whatever industry you're working in. Obviously, 5 years ago, we weren't talking about Blue Cruise. So somebody came up with the idea to use all these sensors that we're looking at in the vehicle and develop such a feature. So be creative is my second point. The third point is demonstrate your ability to manage projects and empower your teams. Bottom line, deliver. So we always work in teams. So we need to be a team player. And also manage many priorities because we don't just have one assignment, we have many. And then the fourth key area is care for each other. This is maybe many of you may say, I've never heard that in the auto industry before, but it's really, we recognize in order for people to excel with their capabilities, we want to make sure we're lifting everybody up, giving everybody a voice so that they can really deliver their full potential. So in summary, I'm just going to say make the most of what your professors and administration are offering you at Tech. You have the opportunity to develop all these skills at Tech. So take the opportunity.
Did you want me to comment, Janet?
I'm leaving it to you guys.
Okay.
Yeah.
I think Bridget,
yes, please.
For all the students that were listening, Bridget nailed so many of the important points here. I think one of the things is it's a grand idea you got to be thinking about is as difficult as getting your undergraduate degree is. It's hard to get your engineering degree for most students. It is just the beginning of your learning. And the way the world is evolving now, particularly in transportation, you've got to cross-disciplinary in your skill sets. Bridget hit on several soft, sort of left brain, right brain sort of stuff. You have to be adventurous. Everything starts with curiosity. So you don't lose your curiosity. The thing that got you into engineering, how does this work? How does it do that? And then you have to get into your calculus and chemistry and physics and all these classes, some of which you may not have been so interested in, but you got to get through them. It gives you a baseline of analytical thinking that you then need to springboard after your engineering degree, particularly now, where you're learning about leadership, you're learning about team building, you're learning about even psychology and why do people act this way and how am I going to be a leader in this organization? A really strong technical background combined with curiosity is really what industry needs more than anything. How things work and how do I work and lead people? This is where it's all going. And I believe one of the greatest needs in our country right now are really, really solid technical people that have great communication skills, because they can think pragmatically and get to the right solution while they listen. Bridget talked about that, and collectively use the talent that you have. That so much of what I'm saying, it sounds cliche, but you students that are listening, it takes a lot of years to figure this stuff out, but you're getting an excellent base at Michigan Tech.
Thanks, Sean.
And it's funny because students who end up taking some of our classes might end up in an English class and say, why do I have to take this? I'm going to be an engineer, right? But the reason you need to be taking classes like that is to learn those communication skills, because engineers have to be able to communicate, and we have to be able to write emails. We have to be able to write reports. We have to be able to read and write reports. And so those courses that may seem like a waste of time end up being some of the most valuable classes.
Well, Janet, I tell a lot of my engineers when I read their emails, prepositions matter. Use them.
Give us an example.
Oh my goodness. I mean, even words like the or to, they lose the intent of what they're trying to say by not writing in complete sentences. I even got a Father's Day card from my daughter with why dads don't text, because she said, Dad, you're so weird. You're writing complete sentences when you're texting. I don't know how else to write.
Oh gosh. Mark, do you have anything to add to that?
No, I think you guys did a great job. I think, Michigan Tech does a great job working in teams and capstone projects and senior projects. All of that's great. There's a lot of small, agile team developments. That's exactly what you're going to do when you get out of school. And working in big international organizations, we have meetings early in the morning or late at night. And it could be with China, it could be with India, it could be with Japan. And to Sean's point, some slang does not translate very well, especially when somebody has English as their second or third language. So being able to communicate clearly can make you much more effective and much more believable, because of different cultures you need to be able to work internationally. And that's a big thing to keep working at.
All right, let's take a technical question from Austin. Do you see a future for hydrogen vehicles?
All right, I've worked in this area too. So hydrogen vehicles, we've been working on them for a long time, and we do have some prototype fleets in the market. There are some challenges in terms of the technology from the standpoint of cold and water do not go well together. And in general, we design our vehicles to go, anywhere in the world. So that's a real challenge with a hydrogen vehicle, is the cold weather. And then the other aspect is the infrastructure, not the roads, of course, but the fueling infrastructure. Again, goes back to, people will adopt the technology if it's easy and convenient to use. And I don't know the last time I've seen a hydrogen fueling station. Probably the last time I saw it was when I was on the Ford campus. So really difficult to introduce a technology when the supporting infrastructure is not available to do so.
I would just add to that we probably are, if once we get millions of electric vehicles on the road, and assuming photovoltaic technology is the source of the ultimate source of the energy, that's another thing that a lot of people don't talk about, is where does the energy ultimately come from with electric vehicles? It's not totally clean if it's coming from natural gas or a coal-fired power plant. So we've got to figure out how do we, there is going to be a variable with millions of vehicles on the road that are using renewable energy that is dependent on weather, whether it's the sun or wind or whatever. How do you store that energy? Fuel cells and hydrogen technology might be the clean way to store energy beyond batteries. But as Birgit said, we're not there yet, but we have to find a clean way to store the energy so that it can be there when people need it, when we have millions of vehicles on the road.
Excellent point. All right, a question from Jeremy. You know, I tend
Sure.
to go for the chemical questions.
So this one's from Ryan Clem, another one of my robotic system engineering students, or I'm sorry, robotic systems enterprise students. And the reason I'm picking it is because I think it covers all three of our guests here. And it's about inter-car communication, but I think we can bring this more broadly to vehicle-to-vehicle communication and vehicle-to-infrastructure communication, and what role that's going to have in autonomous driving. And Ryan's main concern is that this would appear to be potentially a security risk or like a point of failure risk, and wondering whether our panelists might comment on that. So what role do you see vehicle-to-vehicle and vehicle infrastructure communications playing in autonomous vehicles as autonomous vehicle technologies? And then comment also on the security aspects, if you can.
All right. Well, just in general, we do expect increasingly connected vehicles, whether it be vehicle to vehicle, vehicle to OEM, essentially for software updates, with great benefits to customers, both on the front and the back end. So on the front end, if we're providing the latest software, the vehicle you drive out of the dealership will only get better with time, because we'll provide software updates and the vehicle will be better after you drive it out of the vehicle. On the back end, we are looking at data right now from customers, not specific customers. We always take out the specific identifiers of the customers, but in mass, we look at the data to understand how people are actually using our vehicles, so that we can design the vehicles, make sure we're giving customers the features that they're using a lot of, and that they, because of their use, are telling us they need more of. And looking for opportunities to reduce cost and weight in the vehicle for features that people aren't really using. So connected vehicle services are also just in their infancy. I think somebody mentioned that earlier in this discussion. We're just, I mean, we've spent some years already working on that, but there's so much more that we're going to do. From a safety standpoint or a security standpoint, the other opportunity that's growing in our area is that cybersecurity. So we have a few experts in the company now that are working on it, but more and more work in that area. Very important to us that we keep our drivers safe and secure. That's the number one, that's the first question that gets asked. So we are working on it. It's a priority for us to deliver to our customers, and there will be lots of career opportunities there if that's your interest.
Other thoughts?
Yeah, just adding to that, the car is becoming more and more connected, and that's for the safety features and also the connectivity features that we want to bring in the car. And so, inherently there is a threat vector that if you can get into the car, it's going to be there. There's a lot of working groups in the industry already, whether it's SAE or what we call Auto ISAC, which is a group that we're part of. And all of the industry is to just share the information and continue to build these systems stronger and stronger. And we have huge needs for cyber engineers, and it's only going to be a growing field. But the CV2X technology or vehicle-to-vehicle technology, it's going to help with safety. It's going to help with traffic congestion. It's going to help with fuel economy improvements. So it is coming, and we have to just work that cyber angle of it as well at the same time.
Sean, how about, I was going to ask your input, especially on the, a lot of infrastructure is kind of controlled by local city governments, and they're a big target for cyber attackers, right? If they're tied into, a vehicle infrastructure system, it would seem like that'd be another big attack surface, to use the word.
Yes, at a recent conference I was at, a industry expert was saying that local governments really need to be thinking about, do they really want to have all this data? Is that something they want to manage and secure? Her point was that this is really, we use the term in the cloud or some other place, but I think the future is going to be so much more about data management and data security. And I think local governments and public agencies in general at a local level and probably even a state level are going to have to hire out the management of data in pretty sophisticated systems to significantly reduce risk factors. Just like we do now with credit cards and other ways that we manage data so that we can live a life that's not involving too much risk. But that's what I on a local government level, I think we're going to see a lot of that becoming more and more data management handled by the private sector.
Well, there's 7 answered questions, 7 open questions, and I'm going to take this next one from Audrey, which is kind of just about pricing. Is it realistic to be able to buy an autonomous or semi-autonomous vehicle at a similar price as a standard vehicle, say 5 years from now?
Well, I'll give a quick comment on that. I'll let the real experts answer this. But if we think about the commercial airline industry, how many parking lots do we have for commercial aircraft, 747s and 730s? If you go to an airport, where do all the planes park? There is no parking lot because the business model is they're constantly moving. If they're not moving, they're either dropping off or picking up passengers. So we need to imagine a world, the economics of how this is going to work. Our cars will not be owned by people. Cars will be owned by some other entity, and they're always there to serve you. This falls under an acronym of Mobility as a Service, MaaS, where cars, you will simply somehow order them ahead of time or in real time to be there where you want them, when you want them, and they move you through other spaces of other modes of transportation, which could be a bike or a scooter or whatever. Everything will be servicing people. And when I say that, everything, I mean things that move you around. So you won't really buy an autonomous vehicle. Some other entity will have a vehicle to serve you when you need it.
But the point being that the overall cost of transporting yourself a mile or 2 miles or 10 miles might go down or be the same and also be autonomous.
Yes, because when you look at the data right now, the average time that people that own cars, which is most of us, 90 to 95% of the time, it's not moving. So then the economics and efficiency question would be, then why would you want to own something that's not doing anything for you 95% of the time? It's a radical shift in the whole paradigm, and we're on the very beginning of that transition.
Well, and so give us an idea, give us your best guess. I would like to hear from all of you. So mobility as a service with an autonomous vehicle, how many years away might that be?
Sounds like a Bridget question.
Birgit.
Yeah, that's Birgit. I cannot speculate on the future. I mean, you know, in some, I think it's going to be personally, I think it's going to be a progression from what we're seeing, right? I mean, some people already use Uber more than they have their own car. I certainly know a number of, you know, folks that don't have their own car and use these services, but that probably doesn't characterize most people in the US at this point. Again, if we look at Europe or Asia, we're going to find a much larger percentage of people that don't need their own transportation because there's so many you know, options available to get them from point to point. So anyway, I can't speculate on when, but I do think we're already starting the process, and I agree with everything Sean said.
Yeah, that's an important point though, Janet, for everyone, because it's hard to see the major transitions that happen in society. There's so many stories about even the horses to cars. I mean, you read some of the sort of public opinion in 1900 and 1910. And it's comical now because we have the good fortune of knowing what reality ended up being. But most experts are saying there's no question as we go forward, it is just not going to make economic sense to own a car once we get into full autonomy.
Well, I hope it happens by the time I can't see well enough to drive. And I am one of the people, when I go into a place like Indianapolis and I need to get from my hotel to, you know, for the airport to the hotel, I'm not renting a car. I don't know that city. I will do anything besides rent a car. You know, if there's public transportation, that's what I do. If I'm calling a Lyft, that's what I do, you know, so I'm one of those people. I like driving, but I don't like driving places where I don't know the city very well. Well, I think we have time for probably, you know, one more big question, and I'm not sure which question to kind of pick before we wrap it up.
So I'm going to say that my students have been overrepresented here, so I'm going to pick one that I don't know is my student, if you don't mind, Janet. I think it actually feeds right into both of those things, right, that we just talked about. It's from James Harris, and the question is, what does the feedback look like from the public regarding acceptance of ADAS in the last few years? This also includes drivers who've had experience with using the features. And I think this is something that's true across the board for autonomous vehicles in general. You know, a lot of there's a generational component that some people don't want to be in autonomous vehicles at all. They don't trust them, right? But at the other end, or maybe on the as people age into them, or they aren't able to have the freedom anymore, they might very much want to have them. Or maybe on the younger end, there is information telling us that younger people don't want to drive at all. So I'll turn it over to our panel.
I can give just a quick comment that change is typically very hard. And we can all sort of identify with all the ranges of very educated opinions, even on COVID and should I get a vaccine or not. We're in oftentimes this very counterintuitive logic that is not metric based. When you look at one of the first slides Jeremy put up was the number of deaths. Right now there's 40,000 plus deaths in the United States from vehicles, millions of life-changing injuries that cost hundreds of millions of dollars in medical care and lost productivity. Much of it is hidden from the average person's knowledge because we just go on living life and we don't want to know about that sort of unfortunate information. There's no question that autonomous vehicle technology is showing that we can do much better than what humans have been able to accomplish driving vehicles. If we're going to make these decisions on metrics or politics and public opinion, all of it plays a part in how humanity sort of evolves forward. So this is the big test, particularly over this transition period of the next probably couple decades. But if our goal is really to reduce lives and serious injuries, this technology must be embraced.
So I'll add that 40,000, that's actually represents an increase from about 5 to 10 years ago. And most of that is due to distracted driving, as far as I know, right? So there's also that component where we're becoming less safe as drivers.
Yeah, I would just add by 2025, when many of the students will be graduating, that level 2 plus marketplace will become very common. Both of my vehicles are level 2 now, and I won't go back. The automatic emergency braking or the lane keep assist. Once you learn the features, it does take some time. It's hard to go back. But to an earlier point, it's not free, right? Some of these ADAS features add a little bit more cost to the equation, but I have a family, I drive a lot. For me, it makes a lot of sense, right? If you live in an urban center like Boston, maybe you don't even need a car, but everybody does that sort of simple calculation in their head, what's best for them. But the level 2 plus is growing exponentially, and by 2025, it's going to become very commonplace. But there's always a learning curve. Anti-lock brakes took a while. Now they're commonplace. Other technologies that we take for granted. And we as an industry need to teach the consumer better. And some of the ADAS features are hard to learn, but it's going to become more and more popular, and it will help to save lives as well, which is something all engineers are interested in doing.
Well, good. So, we're coming up on the hour, and I promised our panelists that they could have dinner after they finish this. I would just each of you, if you could take a minute to give some closing remarks. And my closing remarks ahead of time is thanking you all 4 of you for joining us this evening. It's been awfully fun. So let's kind of lead it off with Sean, and then we'll do Birgit, and then we'll end it. Jeremy, do you want to give some closing remarks too?
Not at all, no.
All right, so we'll end it with Mark.
Okay, thank you, Janet. I guess students, I would just say that again, you got to pat yourself on the back as you get through this engineering curriculum you're in. You're going to have an absolutely solid base of analytical thinking, rigorous thinking. You have to get through all that coursework you're going through. But really, as you leave campus and have that degree, you've got to have that curious mind that is going way beyond engineering. Both left and right side brain thinking of we're moving into a time where we're seemingly odd collections of skill sets. My son is planning on doing his PhD in philosophy and mathematics. I didn't think those two things sounded like they went together, but as he explains to me, artificial intelligence and other aspects of where smart everything is going, where we have to bring together in civil engineers, which is what I am. I probably don't sound a lot like a civil engineer when I'm talking, but I've been forced into environments with people from other fields of study that, as Birgit talked about, have to work together. The globalization of everything and the speed with which we make decisions. I think engineers are to me some of the best prepared right out of college to move into this world of so many different skill sets that have to blend together to advance the world in civil societies. So I just want to say all that as an encouragement, because most people can't get through an engineering curriculum like all of you are doing, but you can learn a lot of the soft skills if you have a curious mind and an interest and see the value of it, which is hard when you're at a campus like Michigan Tech. But when you leave there and get into industry, embrace all these things that are not engineering. It will serve you well.
Thank you. Birgit.
So yeah, I'm going to reiterate in short what Sean said. Focus on that technical competency, create those great experiences, practice doing that now, and demonstrate your ability to manage exciting projects and empower your teams. And don't forget to care for each other. So, make the most of your experiences at Michigan Tech, and we're looking forward to having you working for us and carrying on delivering the next great product going forward.
Thank you. Mark.
Yes, good luck. There is going to be lots and lots of job opportunities for engineers in the mobile industry or mobility. Cars are cool again, and mobility is cool, and whether it's data science or mechanical engineers or civil engineers, as Sean and Birgit said, you're going to get a core foundation. And I interview a lot of engineers, but it's very simple. When I know you have that engineering degree, I know there's a certain expectation of you can go figure it out, go learn. And the ones that succeed take that on and are successful. Again, I'm a mechanical engineer by trade, but I've worked for a company that's got electric in it for 20 some years. So, should I have been an electrical engineer? I don't know, but right, I've learned a lot on the job, and now we're talking autonomous and perception engineering and computer science, and you just keep learning, and it's great. So enjoy the ride and enjoy the rest of your school years at Michigan Tech.
I will say one thing.
Go ahead, Jeremy.
Yeah, so because we have time, if you're interested in these things, you're looking for a home enterprise, and you're interested in autonomous vehicles, we do have the AutoDrive 2 competition going for the next 4 years. How is in the robotic system enterprise? We'll be having an info session if you don't have an enterprise in ERC 103, 7 p.m. on Wednesday. So feel free to stop by.
Say that a little slower. ERC what?
Yep, so ERC, the Electrical Engineering Building, 103 at 7 p.m. for the enterprise.
All right.
I believe there'll be food. I haven't checked with my leadership, but I will do that tomorrow. But
Pizza.
probably pizza. That's the default food, right? But all the teams will be talking about their projects, whether it's related to AutoDrive or not. So
Awesome. And Jeremy's is one of the advisors for the robotics enterprise. All right, panelists, everyone, thank you so much. It's been really wonderful to spend the evening with you, Sean, Birgit, Mark, and Jeremy. Thanks again for kind of framing the question. And everybody, I'm going to go ahead and close the meeting. And thank you, students, for joining us. It's been a wonderful evening.